In this lesson, we are going to be talking about speed and velocity. By the end of this lesson, you should be able to explain why all motion is relative, be able to define motion and speed, calculate speed by using the formula speed equals distance divided by time, being able to distinguish between constant and average speeds, and explain the difference between speed and velocity. So, last week I had you guys doing a frame of reference lab that had you sitting in a chair, blindfolded, ear-muffed, trying to figure out if you could figure out which direction you were spinning while somebody else was spinning you in the chair. And that gave you an introduction to the frame of reference. But now I'm going to give you a little bit more information on it. So a frame of reference is something that you use to help you describe something that is moving or is stationary. It can be the background behind a moving object or a stationary object, or it can be an object that is just used in comparison. So many of you got this right. You did figure out that a frame of reference was something that you used to figure out if you were moving or if you were stationary. So in our lab, the thing we wanted to know was, did you have a frame of reference on your chair? And generally, you should not have. You may have been able to smell certain things that gave you a frame of reference. You may have been spinning fast enough to feel the wind that gave you a frame of reference. So I didn't stop you from using other senses other than sight and hearing. So did this cause you to struggle when you were trying to move and figure out which direction you were going? Some of you struggled and some of you didn't. So it could have to do with your other senses, or it could just be you're pretty good at feeling yourself move in a chair. So what is motion? Motion is a change in position over a certain amount of time. When you say that something has moved, you're describing its motion. And in describing the motion, you're comparing it with some frame of reference. So if you're going from one side of the room to the other, once you get to that other side of the room, you're going to say you've moved, because you're using everything else in the room as your frame of reference. So we do have these things called displacement and distance. It's a way that we can describe motion. So displacement is a description of a change in position, which is giving a change in distance and in which direction it's changed, whereas distance is just a description of how much ground was covered. So let's do a problem. If a car travels at 4 kilometers to the east, stops, and then travels 3 kilometers to the east, what is the total displacement and what is the total distance? So remember, displacement is distance with a description. So it's the distance from the original starting point. So if we had a car travel 4 kilometers east, if we had a car travel 4 kilometers east, stop, and then travel another 3 kilometers east. This is my original starting point. I would be 7 kilometers away from my starting point. And so the way we describe that with displacement is we're going to be 7 kilometers to the east. Because with displacement, we're not calculating the whole distance that we traveled. It's just how far we're away from our starting point and in which direction. So with the total distance for this problem, the total distance is going to be the same thing because there was no change in direction. So the total distance is also 7 kilometers, but you don't have to put which direction it is from the starting point. Let's try another one. So if you rode a bike 4 blocks north, then 2 blocks east, then 4 blocks south, and finally 3 blocks west, what is the total displacement and what is the total distance? So if we're going 4 blocks north, 2 blocks east, 4 blocks south, and then 3 blocks west, what is our total displacement from our starting point? So this is our starting point right here. And so how far are we from our starting point? Well, we are currently 1 block away from our starting point. And we are west of our starting point because we went 3 blocks west past our starting point. So our displacement is 1 block west. Okay, and what is our total distance? So remember, total distance is total ground covered. So this is going to be all the blocks that we've covered added together. So we've covered a total of 13 blocks. So that would be our distance. Well, now let's talk about speed. So speed. This is the rate at which an object moves or how fast an object moves. So we've heard this all the time. We see it on speed limit signs, we see it in our car, we even may hear it when we're walking on a treadmill or see it when we're walking on a treadmill or running on a treadmill, or we talk about speed all the time. And basically what we're describing when we're talking about speed is the distance traveled in a certain amount of time. So in order to describe speed, we need to know how far we're going and the time it takes us to get there. Constant speed. This is when something is moving at the same speed and it does not change. So this would be like you driving down I-35 at 70 miles an hour with your cruise set. And assuming you don't have to do any lane changes, the I-35 is completely empty, you're the only car on the road, you could drive 70 miles per hour for a while, and you would be going at a constant speed of 70 miles per hour. So this graph here, this is what a constant speed graph looks like. It's a straight line showing you that you are going the same amount of distance in the same amount of time. And then let's talk about average speed. So average speed is the total distance traveled by the total time. So let's say you went and you walked 5 miles per hour for 10 blocks. And then you changed your speed and started running. We would be able to calculate the whole time, your average speed over your whole distance of traveling. And that's what average speed is. So I'm going to link this video in the fun video section for this week for you to watch. It's just basically this woman cannot get it wrapped around in her head that 80 miles per hour means you're going 80 miles in 1 hour. I will link it so that you guys can watch it because it's a really great video. Now let's talk about instantaneous speed. So instantaneous speed is the speed that is measured in an infinitely small amount of time. It's like the speedometer on your car. It tells you the speed you are moving at the exact moment in time that you are looking at your speedometer. So this one here basically says it's going, 61 miles per hour at that exact moment in time.